Okay, ladies and gents, now we're on to something completely different. We haven't done it really so far in grade 8 and 9, and that's what I would call interval notation. So sometimes you want to you've got a set, a group of numbers, 1, 2, 3, 4, 5, or all the numbers between 1 and 2, or all the numbers that are larger than -1 or below 5, okay? And you want to kind of just describe it. I want to say, I want them all to have a group of numbers between, let's start with this one. Let's say all the numbers between -1 and 2, but not including -1 and including 2. So how do I write it? Maths is about notation. We have symbols that's supposed to describe it. So there's two ways that are very easy and you'll get it, no problem. The third way, you'll get it, but it's a little bit confusing. It's a little bit just different, okay? So let's start with this. Let's say I have all the numbers between -1 and 2, but not including -1 and including 2. The easiest way of describing it is what you use a number line. So you've seen a number line before. We've got all the numbers, or not all the numbers, but the numbers I'm interested, okay? And what we're going to do is basically put a line between -1 and 2, okay? And then have a little circle, a white circle of -1, and a black circle of -2. What does that mean? Okay, what is that white circle? The white circle means not including. -1 is not included, okay? The black dot means it's including, okay? So this means between -1 and 2, not including -1, but including 2. Okay, we'll leave these for later. So that's one notation, which is very understandable, I think. It's very intuitive. There's another one, we call that the number line. There's another way of saying it, much easier and quicker, let's say, and that's called interval notation, which is the title of our lesson, okay? So if I want to draw that quicker, what I can do is just put a little bracket, -1, comma, okay, or comma, that fancy comma, and then 2. But here, I'm going to put a rectangular bracket. Why is that? You can probably guess. Because a circular bracket basically means not including, okay? I'm not including -1 in here. It could be -1 or -0,99999 is included, but -1 not, okay? When I have square brackets, that means it is included, okay? So that's pretty easy. Those two are very easy. I like this one. This is the one we're going to use most of the time. Now, I have to show you also the third way. It's called set builder notation. It's more difficult. We're not going to use it too much, but you do need to be familiar with that. And let's put it this way, where you will use it, you will need to be able to read it. You're not going to be asked to use it too many times. There's nothing wrong with writing it this way. That's much easier. But when you get to the trick and you will get some questions, they might not write it like that. They'll write it like this. So you need to know that. It's more formal, okay? So if I want to write this interval in set builder notation, it will be like that, okay? I'm going to write that. You see, I also need to remember. So I'm going to have these funny curly brackets, okay? I'm not really drawing these curly brackets. That's you know what I mean, okay? So all the x's, okay, you see, I also need to remember all the x's. So x is larger than -1, smaller or equal to 2, and then I have to put blah, 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 x belongs to R. Okay, and now I need to explain it. Okay, there's quite a lot to explain here. So, this thing tells me, look, I've got all the x's, so x is larger than -1. I'm sure you've seen that sign. This means x is larger than -1. And this sign says x is smaller, but this little line under this, like horizontal line under the smaller, means smaller or equal. When you just have an inequality sign, these are called inequality sign, that just means x larger than -1. It's not equal to it. A smaller and a half and equal means x is smaller or equal to 2. Okay? So this thing tells you basically, I've got all the x's that are larger than -1 and smaller or equal to 2. This thing tells me, this is really important, you have to finish that, okay? You also need to say what kind of x's are we looking for? And the answer is all the real numbers. If you remember last year we spoke about real numbers, irrational number, integers. So because I have a straight line, that means I'm including all the numbers between -1 and 2. I'm using all the real numbers, whether they're rational or irrational, integers or not integers. Let's move on to the next one. So the next one I've got, again, I've got a dot here above -1, and then a line that goes, but the thing is the line doesn't stop. I've got an arrow that carries on. I think you probably have an idea what that means, okay? So I'm looking here for a number that between, again, -1. What do you reckon? Is it going to be a square bracket or circular bracket? Because I've got a white square, that means not including -1, I'm going to have a circular bracket. But where must I finish it? I'm not going to finish at 2, I'm not going to finish at 3, it carries on. Carries on until when? It doesn't stop. It carries on until infinity, okay? So when it carries on until infinity, then I must put a little infinity sign. That's the infinity sign. It's like an 8 that went to sleep. 8 that just went to sleep, okay? So, and then obviously I can never really reach infinity. So whenever you have some infinity on one of the sides, it has to be circular brackets, okay? So to all the numbers, I've got basically all the numbers between -1, not including -1, to infinity. Now, I didn't draw it here. I'll draw it here, let's say. If I had something similar, let's say from 2 to all the way to all the numbers basically smaller than 2, then in that case, that's going to be, can you think about that? Okay, we're going to include 2, so 2 is the maximum number, and it goes down, 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 down to where? You're right, to -infinity. So -infinity. And then we'll do a circle. So if you have a number interval like this, it would look like that. Okay, how are we going to do the sit-builder notation? Okay, that's always the tricky one. So I'm going to start with drawing this circular, this funny bracket. All the x's, dot, dot, that are larger than -1, right? I'm looking at all the numbers that are larger than -1. Are they smaller than anything? No. So I don't need to write smaller than infinity. I'll just basically say all the numbers that are larger than -1. Okay? Now, you can also write it like this if you want. X is larger than -1. That's kind of alright, but it's not pretty. Okay? It's better to write like this. X larger than -1. Okay? Right, and I'm not finished, then I need to do this bit again, because I'm looking at all the numbers. I've got a line, a smooth line that doesn't stop anywhere. I'm looking at all the real numbers. Okay? Oh, I didn't mention that before, and I should. This sign, okay, this funny sign, I'll make it bigger. It's like an E sign or a euro sign, okay? That means belong, okay? I'll write it down here. This little funny euro thing means belong. It's a funny mathematical notation. All the x's that belong to the real number. Okay? Now we're going to move on to the last one. Oh no, I'm going to actually have another one here. This looks a little bit different. This is the number line. What do you reckon it means? I don't even have a line. All I have is dot, 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 dot. 1, 2, 3, 4. What does that mean? Yes, it's basically the numbers 1, 2, 3, 4. So I'm not looking at all the numbers between 1 and 4. I'm just looking at the integers. 1, 2, 3, 4. In this case, I cannot write an interval notation. I can't. Because interval notation is always all the numbers between this and that. I don't have all the numbers. It's just the integers. 1, 2, 3, and 4. So in this case, I can't really do it. I can't use it. Okay? Okay, but I can use the sit builder notation. Okay, so how are we going to do the sit builder notation? We'll start again. It's all the x. So x is larger or equal to 1, smaller or equal to 4, And by the way, here, when we draw x between two numbers, you must always write the smaller number on the left. Okay? So this, in theory, you can say it like this. X is larger than or equal to 1, smaller equal to 4. This, mathematically, there's nothing really wrong about it, but you don't want to draw it. It's just, you don't draw things like that. You always put smaller numbers on the left, just like on the number line. The small numbers should be on the left. But now, this is where this bit is important. Okay? What kind of x's, I don't know if you guys can see it, I'm just going to see. Yeah, you can still see it. What kind of x's are we looking at here? Is it all the real numbers? Okay, is 1.5 inside there? Is 1.001 inside there? Is 3.2 there? No, because it's just the integers. So I'm looking at only the integers. So in other words, x does not belong to R. Okay, R, okay, if I didn't emphasize it before, are all the real numbers. Okay, in this case, x only belongs to z. Remember we learned last year that z is the letter for the integers. Integers is what you would call in day-to-day language whole numbers. 1, 2, 3, 0, -5, -13, 10,000. These are integers. So I'm just looking at the integers. Okay? Last one. Let's move on to this. So I've got a number line here. I'm just going to check that you guys can see it. Yeah, okay, so you can see it. Okay, what do you reckon this means in the number line? I've got a dot on 1, a dot on 2, a dot on 3. So I've got 1, 2, 3. But what do you reckon this arrow means? You're right. It's also 4, 5, 6, carrying on forever. So in other words, 1, 2, 3, 4, 5, 6, all the rest. Okay, but just integers. This is, if you remember in the language of last year, we said these are the natural numbers. It's the numbers that you call out when you play hide and seek. Okay, 1, 2, 3, 4. Again, because I only have integers, I cannot draw interval notation. There's no interval notation, but I can write down a set builder notation. Okay, so I'm gonna, hopefully you guys can see me there. Okay, I'm gonna have all the x's. Okay, yeah, I'll do it here. All the x's. So x is larger or equal to 1, because it's also including 1. Okay, x is larger or equal to 1. I don't have x smaller than anything because it carries on forever, forever, forever. But I need to mention that x belongs to z, where z are the integers. Okay, now you're ready to do some exercise. Good luck.